Hello, good morning. Good morning. Uh, Let me help my other batch students to join this session. 1 second. Let me copy this. Okay. Okay. Good morning. Um, yeah. Okay. So let me introduce myself. Actually, I am Shiva. Okay. I have overall 8+ years of experience. Okay. So I work with multiple technologies, mainly in the DevOps stream. Okay, so I work with AWS, Docker, Jenkins, Kubernetes, Terraform, shell scripting, Python, and yeah, sometimes Ansible. And yeah, I hold certifications of Kubernetes, Terraform, and official certifications of Kubernetes, Terraform, and AWS. And this is my profile. Okay, so now I think one of my old student got joined. That's fine. Okay, Satish Kumar.
Yes,
Okay,
sure.
yeah. Okay, so this is a new batch that is being starting. Like as we are starting Kubernetes, right? So we have added new batch for the Kubernetes so that people may join as part of this. Okay. So it's general batch only. We'll be dealing with Kubernetes and all things. Okay. So let's discuss about the syllabus that we are going to discuss as part of the Kubernetes actually. Okay. Let me click on.
Are you sharing your screen?
Yes,
It is not
I am.
visible. To
Yeah, I'm going to share actually. Not shared yet. Okay.
Okay.
So yeah. So what are the different syllabus? What is the different syllabus, different concepts, as well as the different projects that we are going to do as part of this course? Actually, we are going to discuss that one by one today. Actually, so let me go here. Let me go to DurgaSoft website, durgasoft.com. Here, we have started a new Jenkins batch as well. I think probably the Kubernetes batch. Yeah, this is the Kubernetes batch. Okay. So this is the Kubernetes batch, and the duration of this course is the 30 days duration of time between 30 and 40. Okay, maximum between 30 and 40. Okay, so we require, as a prerequisite, we require an AWS account for this. Okay, so how to create an AWS account? I'm going to explain. Okay, and uh, as of now, for the today's class, I'm going to explain the syllabus that we are going to deal with as part of this Kubernetes course, actually. Okay. So, Kubernetes, we are going to start with the disadvantages that we have previously with the Docker Swarm and why we are moving towards the Kubernetes. Okay. What's the advantages that you are going to get when you deal with Kubernetes and when we compare to the Docker Swarm? Actually, there we are going to start. And after understanding the disadvantages, we will be saying what is Kubernetes, why Kubernetes, installation of Kubernetes KTS and the kubectl client actually. So kubectl is a client with which you can connect with your Kubernetes cluster. How to do that? We are going to see that. Okay, creating Kubernetes cluster with AWS EKS and the YAML. Okay, we are going to create a EKS cluster with a YAML file. Okay, so now that's the thing. And we are going to understand the architecture of Kubernetes. Okay, we have a Kube API server, we have controller manager, we have scheduler, we have etcd database, we have kubelet, what is kube proxy, what is container runtime engine. All these things we are going to see very clearly. If you feel these terms are technical as of now, just do not worry. it will be clear for you in the course actually. Okay, we will be seeing each and everything as in a practical manner and in a theory oriented manner and a diagrammatic manner. Okay, so all these things. Suppose if you take a concept, we'll be seeing in the three manners actually. Okay, so one is practical, theory oriented, and diagrammatic manner actually. Okay, so something like that. Okay, as part of this introduction, we are going to see all these things actually. And for your information, we are going to create three types of Kubernetes clusters. Okay, EKS cluster, Kubedium cluster, and Minikube cluster. Okay, in real time, EKS cluster is used as part of the industry because you need to get a real-time experience. So that I will be explaining the EKS cluster. Kubedium cluster, why we are using Kubedium cluster? Because sometimes, to practice your labs for your case, you need to spend a lot of cost for the EKS cluster if you want. Okay, to spend very less cost, we will be creating Kubedium cluster and deploying our applications there with the Kubernetes. And to spend less cost than the Kuberium, we can use Minikube. Okay, so like that, to reduce cost, we are using different types of clusters, but in real time, the EKS cluster is used actually to understand that. Okay, so now that's part of we are going to see that all the three things, but based on the lab, you can create whatever the cluster you want. I'm also going to show you online cluster. Okay, you can have the cluster online and you can practice your Kubernetes labs there as well. Okay, so that's the thing. Once this introduction and the tools installation got completed, okay, uh, we will be moving towards the Kubernetes workloads and resources. Okay, as part of the Kubernetes workloads and resources, we'll be seeing init containers, pods, replica set, deployments, daemon set, jobs, cron job, stateful set. All these things we are going to see as part of this. When to use init containers, when to use pods, when to use jobs, when to use cron jobs, when to use daemon sets, when to use deployments, all these things we are going to see actually. Explanation of multi-container pods. Okay, what is this? Multi-container pods actually. Okay, we can put multiple containers as a inside a pod actually. Okay, so we are going to see that very clearly. And imperative and declarative commands for Kubernetes. Okay, imperative and declarative commands for Kubernetes actually, because imperative way is very useful if you are planning for the certification. Okay, while writing certification exam, okay, you need to save the time a lot. In that case, you need to use the imperative commands, to perform some action on the Kubernetes clusters. Okay, so we are going to see that imperative way. Everything will be in practical, which I've already mentioned. Okay, now after completing this, we are moving towards the Kubernetes services and the load balancing. Okay, understanding different types of services we have. What is the cluster IP? What is a node port? What is a load balancer? What is the cluster external name? What is a headless service? All these things we are going to see. Understanding multi-port services, everything in practical manner, and understanding the DNS for the service and the ports, actually something like this. Once the service has got completed, we will be moving towards the storage. In the storage, we will be seeing understanding volumes in Kubernetes. See, as of now, if you feel technical, please do bear with me. It will be very clear when we discuss the concepts. Okay, understanding volumes in Kubernetes, persistent volumes and persistent volume claims, empty diff, host path, static volume provisioning, dynamic volume provisioning, and storage classes. Everything we are going to see here in the practical and everything. Okay, everything will be practical, which I've already mentioned. Okay, all these things. Okay, now after completing the storage, we are going towards the configuration of Kubernetes workloads. We will be saying config map, secrets, sealed secrets, okay, requests, resource requests and limits, resource quota, limit ranges, quality of service classes. Okay, all these things will be covered actually. It is very important, all these concepts for the interview purpose as well. Okay, understanding different types of deployments and significance. We have something called rolling updates and recreate type of strategies we are going to see as part of this. We are going to see horizontal for autoscaler. What is this horizontal for autoscaler really mean? It's very interesting actually. Suppose there is a sale in your website, right? Um, suppose Amazon.com. Suppose let's think Amazon.com is hosted on the Kubernetes cluster, and there is going to be a sale in the Amazon.com. Right. So lot of users will be accessing the Amazon.com website, right? So based on the amount of incoming traffic, the Amazon.com website should be automatically scaled. Okay, Amazon.com website should be automatically scaled. Okay, so scaled means increase its capacity. Okay, so that is will be done by the horizontal product scaler as part of our Kubernetes. We are going to see after that image full policy. Okay, we have three types of image pool policies: always, if not present, never actually. So all these things we are going to see: command line arguments, commands and arguments, and advantages, explanation of namespaces, readiness probe, liveness probe, and startup probes, and practical examples. Everything will be in practical session. Okay, once this configuration got completed, we will be doing a project. Actually, I'm going to show you the project presentation in the next uh, today itself, in the next slide, or after this syllabus explanation. Okay. So once the project got completed, we will be moving towards scheduling. As part of the scheduling, we will be seeing different types of scheduling algorithms. Okay. Manual scheduling, we are going to see using node name and using labels and selector. What is scheduling actually? We are going to understand that first. Okay. We are going to understand what is scheduling, and then we will be moving further with that. Okay. So we will be saying node name, labels and selectors, taints and tolerations, node affinity, pod anti-affinity, all these things we are going to see in a practical manner and a diagrammatic manner. Okay. So all these things. Security. Once the scheduling got completed, we will be moving towards the security, understanding service accounts. What is service account? Where we need to use service account, in which cases you need to use service accounts. We are going to see that. Role-based access control. Okay, we are going to see it's very important. So suppose you have a Kubernetes cluster. Everyone in your organization should not have entire cluster access, right? Okay, based on their role. Suppose if you are a developer, okay, the developer should be having okay, certain amount of access in the cluster. Okay, the tester should be having certain amount of access in the cluster actually. The administrator of the Kubernetes should be having entire cluster access, something like that. How to control that access using role-based access control, or that we call it as. This will be achieved using role binding, cluster role binding, all these things we are going to see. We are going to see the static parts and practical examples and use cases of security. Okay, once the security got completed, we are going towards the networking. In this networking, we are going to see host-based routing and the path-based routing. What is an ingress? We are going to see. What is ingress controller? We are going to use the two types of ingress controllers: Kong ingress controller and Nginx ingress controller, and perform path-based routing and the host-based routing to our applications deployed in the Kubernetes cluster from the process, actually, something like that. Okay, so we are going to understand that one. We are going to understand the network policies and the use cases with that network policies, everything in a practical manner. Okay, once the networking got completed, we are going to do the project as part of after this networking. Okay, and then we will be moving towards the monitoring and troubleshooting. As part of the monitoring and troubleshooting, what are the different problems that we may face in real time when you are working? Actually, we are going to see that all the problems and uh, problems uh, and solutions for them. Okay, suppose if this is the problem that is been occurred, this is what the solution we need to understand, something like that. Okay, so here uh, different logging, how to check the logs of our application, and how to monitor your applications and your how to monitor your Kubernetes cluster. We are going to see as part of this monitoring. We have uh, Prometheus and like that project in order to monitor. I'm going to explain you that project as well, but yeah, that's fine. Okay, different issues that may occur in Kubernetes cluster actually. Visiting logs and describing applications to debug applications, understanding the problems and the significance, monitoring cluster using Kubernetes dashboard. Kubernetes dashboard is also one of the application where you can monitor your uh, cluster actually. Okay, we are going to see that actually as part of monitoring and troubleshooting. Sorry. Once the monitoring and troubleshooting got completed, we will be moving towards the Helm chat. Okay, we are moving towards the Helm chat, introduction to Helm chat, installing Helm chat and working with it, commands used to deploy applications with Helm and the explanation, working with Helm and explanation of folder structure, functions, conditions, loops in Helm, Helm templatizing, and named templates actually. Okay, project on Helm actually. We are going to have a full-fledged project on Helm and deploy that as part of our Kubernetes cluster actually. And last but not least, we are going to see a project on Argo CD, which performs automatic deployment to our Kubernetes cluster. This is the different syllabus that we are going to address as part of this course. Uh, that's a thing actually. If you feel technical, do not worry as of now. Everything will be clear as of uh, when we address them in our course actually. Okay, anyone have any questions regarding this syllabus? If not, I will be going towards a project presentation.
So, sir, one thing to ask,
Mhm.
do we need any prior knowledge of some of the technologies or some things to start with this, or like it is from scratch only?
No, actually, a prior knowledge, not a big knowledge is required, but a small knowledge is required using Docker. Okay, because Docker is a container runtime engine, and the Docker images you need to understand where we are using the. If you do not have, uh, you should have that knowledge actually uh, about Docker, some knowledge, not.
I know about Docker and like I am familiar with Kubernetes also, but like
Mhm.
not in that much. So like I am just a kind of user of Kubernetes dashboard. So
Mhm.
I don't know in depth
Then,
of how the things work. I know
then
about
that's fine.
deployment, scaling, and other stuff on this, but not
Mhm.
in that much depth. So, like, would this like be fine to start?
Yes, if you know little bit of Docker also, it's fine to start with Kubernetes actually. Okay, because we are going to use the Docker images as part of this Kubernetes cluster. We are not going to internals of Docker, but internally Kubernetes will be using Docker container runtime engine like Docker, but we are not going to internals of the. We are going to use the Docker images as part of this Kubernetes. It's enough
So,
for
for
that.
the Docker part, we will means a Docker file. Are we going to write Docker files or
Yeah, we already have a Docker files.
okay,
If you want, I can show you from scratch how to convert an application, uh, a Spring Boot application to a Docker image. It's some 10 minutes, something like that. And we are going to convert that into a Docker image. And that image can be used in order to deploy into the Kubernetes cluster. It's simple.
yeah.
Okay. That's a that's a different stuff we are going to see actually. These are the different Kubernetes concepts that we are going to see. Any others have any questions, please? And one prerequisite is you should have a AWS account. Okay. It's very easy to create. It's same like your Instagram creation, account creation. Okay. Now these are the different topics that we are going to discuss as part of the Kubernetes. Now let's move towards the project's presentation. Let me open this and let me do all these things. Okay, not this one for you. Okay, this is the first project where we are going to deploy two-tier application to our Kubernetes cluster, and we are going to store our Docker image as part of the ECR. Okay, something like this. You can see that ECR. First microservice will be taking the image from the ECR, and the second microservice will be taking from the image from the hub.docker.com. And we have used different concepts as part of this. We have used PVC, PV, storage classes, dynamic volume provisioning, pods, services, deployments, replica sets, horizontal protoscaler, secret, config map, resource requests and limits, namespaces, resource photo, job, and cron job. All these things we are going to see. If I explain this project, it will be not understanding for you, most of the people, but yeah, that's the thing. Uh, why these cron jobs and jobs are used to take up, they are used to take a backup of our data from our applications and store it on the node or somewhere in the cloud or somewhere wherever we have configured to store the data to. Okay, so this is what the project that we are going to do. We are going to deploy two-tier application with a Kubernetes cluster, and after completing the configuration topics that I have listed previously, actually. Okay, so that's the thing. Once this project is completed, we are going to move towards a project number two. This is a project number two, where the security and the networking in place, the additional thing. Here also, we are going to use Nginx and the Kong ingress controllers, or any one of the ingress controller actually, but I'm going to show you the demo for the two. But yeah, for this project, we are going to use any one of the ingress controller, and we are going to perform path-based routing and the host-based routing to the backend applications that are deployed in the Kubernetes cluster actually. Okay, so we are going to purchase a domain in the GoDaddy, and we are going to map that domain in the Route 53 uh, with the load balancer that is going to be created by the ingress controller. And we are going to do that stuff actually. If I explain enough, it will be like in the air or something like that I'm explaining, and you'll be confused. But yeah, the additional part that is being uh, added to this project is networking and the security in the project number three, actually. Okay, that's the thing. That's the project number three we are going to deploy. See, actually, now the project number four is the Helm chart. Okay, the Helm chart deploying into the Kubernetes cluster, how to create a Helm chart for our WordPress and the MySQL application. Suppose WordPress is one microservice and the MySQL is one microservice, and WordPress is dependent on MySQL, right? So because WordPress stores the data to the MySQL database. Okay, so how to create a Helm chart for this, and how to use different functions, how to use different values.yaml file based on your environment. Okay, all the things are there when we deal with Helm actually. But yeah, it is tough to explain as of now because yeah, that's the thing. Just understand because yeah, that's the thing. Okay, we are going to integrate our Kubernetes cluster with a this what is this Kubernetes dashboard as a K9 and K9s tool. K9s, is one of the client-side tool where you can also visualize the cluster like the Kubernetes dashboard. Okay, something like that. In the middle, you can see that here, right? This is a K9s tool. Okay, and this one is a Kubernetes dashboard tool, as you know already, some of you. Okay, so that's the thing actually. Now, after doing this project number four, we are going to do this EFK stack. What is this EFK stack? Suppose you have deployed the applications as part of your Kubernetes cluster. Okay, you have deployed your applications as part of this Kubernetes cluster. How the application logs are collected from the cluster and send it to Elasticsearch, and from the Kibana, we are we will be fetching the application logs and we'll be seeing as per the Kibana dashboard. We are going to see this EFK stat uh, project actually. Okay. Once this EFK stat project are completed, we are going to see the project number six, which is monitoring. This is logging project. Okay. This is monitoring project. Okay. We are going to integrate our Kubernetes cluster with Prometheus and the Grafana, and we are going to get the alerts to our Slack channel using alert manager. We are going to use a component called alert manager. Whenever an application is down in the Kubernetes cluster, you are going to get immediately alert to your Slack channel sir, saying that this application is down, so that you can work on that application. Why it is down, actually, something like that. Okay, so that's a monitoring project we are going to see, and we are going to see various options that are available in the Grafana dashboard, like what is the data source, and what is annotation, how to share the dashboards. Okay, there are how to create a playlist, how to integrate the playlist with your TV. Uh, like that, we have uh, something like that. Different options are there. Okay, we are going to see all the options that are there as part of the Grafana dashboard actually. Okay, something like this as a project. Okay, so this is a monitoring project. This is a logging project. This is a packaging project, the Helm packaging project, and this is the networking project. And this is going to be uh, the two-time deployment project actually. First, you need to understand this, then only the other projects you will be able to understand actually. Okay, so that's the thing. Once that is, this is optional. I've uh, it is not included for you. Actually, this is not a project actually for you. It's a optional. It's deal with STO, a service mesh, and we will be monitoring the STO traffic management with the Kiali is one of the tools. This is optional project for you. Okay, the other project we are going to deal with is the Argo series, which I've already mentioned. I have put the two different projects in the same project number 4, but they are individual projects actually. The Helm chart is one project and the Argo series is one project. Argo CD is used to perform automatic deployment to your Kubernetes clusters actually. Okay, Argo CD is a tool with which you can integrate with a GitHub repository. Okay, whenever there is any change that is happened in the GitHub repository, the Argo CD will be performing automatic deployment to your Kubernetes cluster without any manual interaction with the Kubernetes cluster. Okay, we are going to see that Argo CD tool, something like that. Okay, see, we are going to use many tools. Like example, Argo CD, Helm is one of the tool. We are going to use this tool called uh, the Postman, and we are going to use the kubectl, kubeNS, kubectl, uh, EKSCTL. All these tools we are going to use as part of this course because yeah, uh, that's the thing. Actually, that that's how we deal with actually. Okay, so that's the thing. Okay, these are the different projects that we are going to see as part of this course. Uh, okay, so anyone have any questions, please? Is that is that good or projects? Is that interesting?
These artifacts we can do with the free tier itself, or do we need to have any pay as to go kind of?
Which artifact you mean?
This all project related tools and everything in the AWS. Does it comes with the free tier or?
No, no, it does not come with a free tire.
Okay. On an average, how much we have to spend on this?
On an average, if you after doing lab, if you delete, you should delete immediately after doing lab. It depends on entirely how much time you are running your cluster. Okay, you will be charged for running your EKS cluster. It entirely depends on the how much time you are running your cluster. To understand the cost, to understand the cost of the EKS cluster, just go to this place and EKS cluster pricing. Okay, Amazon EKS pricing. Just go to this place and just create a custom estimate or this. Click on this. Put something in chat. Okay, now number of clusters is 1 and number of no, I want to make it 0. Okay, so number of cluster is 1. Show calculations. You can see that here. One cluster 0.10 USD per hour, and if you run for 750 hours per month, then that is 73 US dollars. That's what the pricing of the EKS cluster will be. Okay, and it depends on the region to region. And if you go to the Mumbai region, we are going to use mainly the Mumbai region. It is $0.10, you say. Okay, so you can, this is what the EKS cluster charges. And and it's only for the EKS cluster charge. Okay, if you when you create an EKS cluster will be creating a NAT gateway, a elastic IPs, and different infrastructure will be created by the EKS cluster. Those will be charged separately, and mostly you will not exceed more than $1 per hour actually. Okay, you will not exceed more than $1 per hour. Okay, that's what I can say. Whatever the maximum, you will be charged for $1 per hour. That's it. Is that clear?
Yeah. Do we need to know any shell scripting or kind of Linux
No.
in this?
No. Yes, if you have, it's well and good actually, but it's not a prerequisite to have. Mhm.
The same
Okay.
concepts we can take it through the Azure also, right? I mean,
Yes, yes. See, whatever the concepts that is there, I've listed before you, all these things. It's same for GCP, it's same for Azure, AKS, it's same for EKS, it's same for if you are using bare metal clusters like COPS. Okay, so whatever the concept, whatever the clusters you take, these are the common concepts. It's not the dependent concepts actually. The common concepts across the clusters, across the clouds actually. Yes.
okay. With this course, can we prepare for certification?
Yes. You can prefer for CKAD. And some of the CKA concepts are also included, but yeah, you can prepare for CKAD.
Is the recordings available? I mean, if in case any
Yes,
classes we
yes.
miss.
You will be getting 6 months of recordings, and that will be you can access recordings for 6 months, and you'll be getting the drive access where your recordings are also available there.
Okay. Is there
Yeah.
any, I mean, online links you can give for brushing up the Docker side? Because I'm very new to this Docker and Kubernetes.
Yeah, I can share you at the last session, or let me stop screen sharing and share you the link, and then again let me screen share back. Okay, let me go to YouTube because yeah, let me go to Windows. See what I can do. What I can do, I can request DurgaSoft people. Okay, anyway, you are going to get a drive access for Kubernetes. Kubernetes sessions. I'll request for DurgaSoft people to upload the Docker sessions also. And until that time, we have some recordings as part of the YouTube. Let me share that playlist link with you people so that it will be easy for you to start with. Second, is it mine? Yeah, it's mine. Now let me share you the link. Anyway, I'm going to request. Mostly they will be they'll not say anything. Okay, so everyone I'm waiting. This is a playlist link where you can find the sessions regarding Docker. The missing sessions or all the sessions of Docker, I will be asking those people just to upload with you people. Is that fine?
Yeah, thank you.
Yeah. Mm-hmm. Where is my this to share the screen with this form? Let me share the screen one more time. Okay. So how I'm going to support you if you have any questions regarding the Kubernetes while practicing, you will be added to the Telegram channel, Telegram group, I mean. Then your questions will be solved as part of the Telegram group. Or if your questions are not solved as part of the Telegram group, uh, we will be correcting uh, online through Google Meet whenever you have time, and I have time, then we'll be solving your problems that you face as part of when you are practicing your labs. Okay, so that's what we are going to do, and different interview questions are also you are going to get at the end of the course. And yeah, the YAML files I'm going to upload to the drive so that you can get the uh, YAML files and to practice. And yeah, these are the different concepts in the projects and these are the different things that we are going to do as for the course actually. Okay, so just I want to help you with the terminologies of Docker, sorry, Kubernetes. Okay, so let me close this one and let me go to the paint actually. So in the Kubernetes, we will be having a terminology called node. Okay, so we will be having what is a Kubernetes cluster. What is a Kubernetes cluster? Kubernetes cluster is a combination of multiple nodes actually. Okay, nodes means here it's a machines. Okay, this is the cluster, and in this we will be having multiple nodes, something like this. Okay, Control C, Control V, and here something like this. Okay, so this is first node and this is second node, and this is going to be the third node. Node means it's a machine, server. Okay, so that's a node actually. This is the Kubernetes cluster. Okay, so this is going to be a Kubernetes cluster. K8s, the shortcut for Kubernetes is K8s, and this is going to be the node 1, and this is going to be the node 2, node 2, and this is going to be my node 3, node 3, something like that. Okay, so here is entirely a Kubernetes cluster, and individually these are internal something called nodes actually. These are nodes of this Kubernetes cluster where you are going to deploy your applications in these nodes actually. Now, how you are going to deploy your application? Suppose you have deploy means placed your application on the node. This is something called pod in the Kubernetes terminology. Okay, this is something called pod. Okay, your applications will be running as part of the pod in the Kubernetes cluster actually. Okay, this is something called pod. Inside this pod, your Docker container will be running. Inside the container, your application will be running actually. Inside your pod, your Docker container will be running. Inside the container, your actual application will be in running stage. Okay, so but in Kubernetes, the smallest unit is something called pod, but not the container. Okay, so in the Kubernetes, actually, the smallest unit is pod, but not the container actually. Okay, so you will be deploying your applications as pods in the Kubernetes cluster, but internally, your pod contains a container. Inside the container, your application will be in running state. Okay, that's what you need to understand from this place actually. Okay, so this is what the just terminologies that you need to understand actually. One is the cluster. What is cluster? What is a node? What is a pod initially? Okay, this is the three terminologies that you need to understand. Now, before before creating with Kubernetes cluster, how we are going to connect to the Kubernetes cluster. Let me explain. First, let me help you with the setup. Because without the setup, without understanding the setup, you cannot practice a lot and you'll be stuck in this place itself. Okay, so I will be explaining you with the help of the diagram and the setup related part, and we'll be moving further with that particular Kubernetes actually. Now, what we are going to do here, we are going to have, this is a AWS cloud. Okay, this is a AWS cloud. Okay, this is going to be a AWS cloud. Let me label this one. Okay, this is the cloud, AWS. In this AWS cloud, we are going to have our cluster. Okay, we are going to have our Kubernetes cluster. Okay, it's a EKS cluster or whatever the cluster, Kuberian cluster, whatever the cluster it is, we have the cluster. Okay, this is going to be the cluster. Okay, Kubernetes cluster. Okay, cluster, I'm referring to Kubernetes cluster actually. Now, as part of this cluster, we have multiple nodes. This is first node. Okay, so this is going to be the second node. something like this. And this is going to be the third node that we have as part of this cluster. Okay. Now, in order to perform actions with the Kubernetes cluster, you need to connect to the Kubernetes cluster. How you are going to connect to the Kubernetes cluster actually? I am going to show you the two different ways. If one way is not possible, you just try with the other way. Okay, so how to connect with that Kubernetes cluster? What you need to do, you need to create one more machine, something like this, a server, something like this is the server. This is something called Bashan server. We are going to call it as just it's a name. It's not something different. It's a server. We are going to create the server in the AWS, and we are going to access the cluster from this server. Okay, so something like this. We are going to access the cluster from this server. Something like this. Okay. Other way, we are going to access the cluster from your local machine. Local machine means your laptop. Okay, so this is your laptop. Okay, you will be able to access the cluster from your local machine. I'm going to show you the two different ways, but whichever possible for you. Some Windows laptops will not be supporting something to installation something. Something means the kubectl you need to perform some path setup and all the things. If you feel that difficult, just you can use this virtual machine or the machine to connect to the cluster, or you can use WSL in your local machine to connect to your cluster, actually something like this directly. Okay, so I am going to show you the two different ways to connect to your cluster. One is with your Bashan instance and other one is with your local machine. So in the two different ways, we are going to connect to the cluster, that means Kubernetes cluster, which we have actually. Okay, so that's someone put something in chat. Yes, yes. AWS server means it's easy to machine. Yes. Yes, you're right. Okay. So these are the different this is how we are going to connect to the cluster actually. Okay. So how to create a cluster? How to create a cluster now? Okay, let me go to my place. Go here, Kubernetes clusters. As of now, just concentrate on creating the cluster. What are all the different things you that's as of now, do not concentrate on that. Just focus on just creating the cluster. If you focus on all the related things, this will be going. Okay, so just go to this YAML file. Just focus on what is this YAML, what is this node groups, what is this region, what is this name. I'm going to explain very clearly in the future. But as of now, just focus on how to create a cluster. That's it. Okay, so this is the YAML file that we have. Okay, this is the YAML file. This is the YAML file. And go to the path where this YAML file is there. Okay, cd // Kubernetes clusters AWS EKS. Okay, in this place, we have our cluster config.yaml file. Okay, now execute this YAML file. Execute this YAML file, your cluster will be ready. How to run this YAML file? Using EKSCTL tool. You need to install EKSCTL in your local machine, or if you are using Bashan instance, as shown in the diagram, this one, you need to install EKCTL on this Bashan instance. Okay, so you know to create a cluster. Okay, now go to
So
the
one
path.
ask here,
Yeah,
like
yeah.
KSCTL is similar to kubectl command, right?
No. EKCTL is different.
Okay.
kubectl is different. It's not similar to EKCTL.
Okay.
See, let me differentiate. kubectl is a command to interact with the Kubernetes objects. That means your pods, Kubernetes pods, your Kubernetes persistent volumes, your Kubernetes persistent volume claims to interact with to perform actions on these particular objects, Kubernetes objects, you need kubectl. But EKSCTL, you need EKSCTL to interact with EKS components like node groups. As part of what is node group, I'm going to explain, but yeah, that's the thing. To interact with EKS components, you need EKSCTL. But in order to interact with Kubernetes components, you need kubectl. So that's what the differentiation. Okay, so now that's the thing actually. Now you are going to use EKSCTL tool in order to create a cluster. EKSCTL create cluster -f cluster config.yaml. So that's what the command that you need to use. Just click on enter. Okay, now your cluster will be created in next 20 minutes. Okay, so that's what you need to create your cluster. In order to, if you are using your local machine in order to create your cluster, please give me the information who are all using the local machine, because you need to do some setup in your local machine. You need to configure AWS CLI. You need to configure access keys and secret keys in order to create your cluster from your local machine. You need to do these things so that you will be able to create the cluster like this, which I am using here actually. Okay, this is one way of creating cluster from my local machine. That means, okay, as part of the diagram, this is the local machine. I'm doing the creation of the cluster from my local machine. The other way is from the Bastion instance. Here you don't need of, if you are creating from the Bastion instance, you don't need of doing any configuration. Okay, so what you need to do, go to your AWS account, Here is your AWS account. Here it is. Okay, so how to create a Bastion instance is click on launch an instances, give instance a name, just a name, just test. Actually, whatever the Amazon Linux, just I'm selecting the operating system as Amazon Linux, and just your instance type. Just I'm using the t2.micro. What is its instance type? Based on this instance type, the amount of CPU and amount of memory will be allocated to your machine actually. Now, as part of the key pair, just proceed without a key pair and click on this. As part of the networking settings, just click on this, select existing security group and select the default security group, and just give some storage. I don't want to give any storage. Just click on launch an instance. Okay, launch an instance. Your Bastion instance is launched. Now, let me click on refresh. You can see that test Bastion instance is in pending state. Once it has come into running state like this, something like this, and 2x2 health checks passed, what you need to do, you need to click on that Bastion instance, something like this. Click on connect and click on connect. Okay, your connection is going to be establishing. You can see that you are establishing your connection with your server. That means your Bastion instance. This is a instance or a server, EC2 machine, or this is the instance. I am inside. This instance now. Just remember. Okay. Now, from this instance, you can create your EKS cluster. Okay, without any problems. Okay. Now you can create from the local machine, and you can create from the EKS in EKS server. Okay, this Bastion instance. Okay, here you need to copy that file to this Bastion instance. Okay, sudo su hyphen, let me switch to root user. Okay, so here we have the cluster config.yaml, right? Same file which is there in my local machine. You need to copy the entire content of this file and put it in this vi cluster create cc.yaml. Let me create a file cc.yaml and let me copy this content. Okay, command A, command C, and put it here, paste it here, something like this. Escape :wp, save that file. Okay, so we have a file called cc.yaml here. Where is that? You can see that cc.yaml, and Just execute the same command, eksctl, eks. You need to install eksctl before executing this command. Actually, eksctl is a tool you need to install. Just go to the new tab, eksctl install. Okay, so just go to eksctl installation page, and you'll be finding different commands to install eksctl for Unix, for Windows. If you want to install in your local machine, and using Docker also, you can use eksctl actually. Okay, something like this. Okay, now go to that machine. Where is that machine we have? Okay, this is a machine. Just execute a eksctl create cluster -f cluster cc.yaml, right? cc.yaml. Then just click on enter. Your cluster will be created within next 20 minutes. Okay, so this is how you can create a cluster and interact with the Bashan instance from the Bashan instance. And here is how you can create a cluster with your local machine. Okay, something like this. Okay, so these are the two different ways of creating cluster of EKS cluster. One is from your local machine. Second one is from your Bashan instance. Because why I'm showing from the Bashan instance? Because some of your people, not most, some of the people laptops will not be supporting uh, uh, some softwares to be installed. I've seen this for my previous batches actually. So that is why I have provided them an alternative approach to create a cluster and to interact with the cluster from this Bashan instance, and they are able to do that fine without any problem. But yeah, most of the time you should be able to connect actually. But yeah, we don't know, right, what's the problem with your machine. So in that cases, you need to just use the Bashan instance. Okay, when you are creating EKS cluster, if you face any problem, I am there. Please help me with your information. What's the problem you are facing? And if possible, it will be solving there itself. If not, we'll be connecting separately and solving your problem, whatever problem you have actually. Okay. So that's the thing. That's how we are going to deal with. This is how you need to create an EKS cluster using eksctl and the cluster config file, which I have shown you actually. Okay, you can see that this is the cluster config file. What is this file? What are the different meaning of this file? Do not worry as of now. I'm going to explain the next class, that is tomorrow's class. Okay, what is this? All these things. What is the node group? And what is this desired capacity and the instance type and the volume size and public key name? All these things I'm going to explain. Okay, so that's a thing actually. This is just creation of the EKS cluster and the different things actually. Okay. Anyone have any questions, please, in today's class? New people and the old people. Not sure. Are you people getting the points or?
Yeah, it's pretty much clear.
Okay.
It's
Okay,
okay
so
for me.
Mhm.
It is okay for me. I think the syllabus is very interesting. I think I will enjoy the course.
Yeah, thanks for that. Someone is placing something. Yeah. We use kubectl when we interact with Kubernetes. Yes, we use eksctl when we use EKS cluster. No, when we use EKS cluster, also we are going to use EKC. See, you need to understand, Satish. Here there will be two components. One will be EKS cluster components, and EKS cluster is also one of the Kubernetes cluster and Kubernetes cluster components. In order to deal with Kubernetes cluster components, we will be using kubectl. In order to deal with EKS cluster components, we will be using eksctl. Okay, that's what the difference is actually. Okay, so here EKS is also one of the Kubernetes cluster. EKS has separate components. Our Kubernetes has separate components. In order to interact with the Kubernetes components, which I've already mentioned, you need to use kubectl. In order to interact with the EKS components, you need to use eksctl. Like one of the example. Kubernetes components, one example is pods. You need to use kubectl. EKS components, one of the example is node groups. You need to use EKSCTL to interact with that. Okay, so yeah, I understand there will be confusion between the EKS components and the Kubernetes components because EKS cluster itself a Kubernetes cluster. Okay, but yeah, there is a difference between EKS components and the Kubernetes components. Actually, you cannot find the node groups as part of the Kubernetes components. Actually, okay, so Kubernetes components are different. EKS components are different. Actually. Yeah, that's the. And what is this node group and all these things? I'm going to explain the next class with the help of the diagrams. Okay, so now just the cluster creation I've explained. Yeah, that's fine. Actually, on next step rollback, that's fine. In your case, you will not be facing this issue because I am facing this issue because of the payment not has been done. Okay, so that's the thing. That's the class for today. And whoever all the new, please go ahead if you are interested. Go ahead and register for the course. And tomorrow is the last demo for this this Kubernetes, and day after tomorrow, the link is going to be changed. If you're interested, please go ahead and register for the course. That's what I can say. And thanks for joining. And it's great time to meet you people. And we'll meet in the next class at the same time, 9:30 a.m. Thank you.
Thanks.